Spray drift is the physical movement of spray droplets through the air at the time of application or shortly after application, from the target site to any non-target or off-target site. Reducing or avoiding drift should always be a top priority when you spray.
It's frustrating and worrisome to watch expensive and potentially dangerous crop inputs float away on the wind. The most recent and perhaps most promising development in spray nozzle technology is actually an improvement on technology developed and then abandoned in the 1950s. With the introduction of the air induction nozzle, farmers and commercial applicators are much better able to control spray drift than they were 5 years ago.
Air induction, air inclusion, or Venturi nozzles are different names for the same technology. When these nozzles first became available to farmers, manufacturers had difficulty keeping adequate supplies in stock. The main reason for this interest is the dramatic reduction in spray drift that air induction nozzles offer when compared to traditional nozzle designs. The potential for spray drift exists every time you turn on your sprayer. Hydraulic spray nozzles will always produce some very fine spray droplets that will drift. These spray droplets are called driftable fines. Some air induction nozzles produce less driftable fines than others. No matter which product you are spraying, there are always fine droplets that can drift, and these droplets do contain spray chemicals. One way to reduce this drift is to use one of the new air induction nozzle designs that produce significantly less driftable fines than any flat fan nozzle. So, how do these new nozzles work? There are a number of different types on the market, but they all operate on the same principle. Air induction nozzles, otherwise known as Venturi nozzles, draw in air that mixes with liquid to produce coarse spray droplets. This principle is called air entrainment, and it is nothing new. Kitchen and bath faucets use air entrainment in the strainer to add air into the water stream. This makes the water stream softer, so that as your hands pass through the aerated water stream, the water flows gently over them without splashing. Air induction, or Venturi nozzles, use this same principle of air entrainment.
Most spray applicators think that these nozzle designs have only been out for a few years. In fact, here is an air induction nozzle manufactured in the 1950s. A poor spray distribution was one reason this style never caught on. But that problem has been solved, and the nozzles now manufactured have very good spray distribution patterns.
Let's take a closer look at what is happening inside the nozzle. Spray liquid is pumped through the nozzle. The liquid passes through an hourglass-shaped chamber. As the liquid passes through the narrow part of the chamber, a negative pressure is created which draws air in through the air inlet holes. This air is mixed with the spray liquid. The spray droplets exiting the tip contain air bubbles. Manufacturers claim these nozzles provide good spray coverage with large droplets because the air-filled droplets are more fragile and shatter or explode on impact, providing spray coverage comparable to conventional tips. Concerns about drift are even more critical at this time in agriculture. The trend in herbicide application today is to use less water per acre. Less water per acre means smaller nozzle sizes. Smaller nozzle sizes produce more driftable fines. Venturi nozzle technology addresses the drift concerns in the smaller nozzle sizes. Some changes in crop genetics and cropping practices have reconfirmed the necessity of avoiding spray drift. More no-till acres are being planted, resulting in the use of more burn-down products to control weeds before planting or after harvest. Most of the burn-down products are non-selective and will kill or injure any green plant material. Many new herbicides are becoming available that need to be applied within a small window of time. and are sprayed after the crops and weeds emerge, when there may be susceptible crops already growing in adjacent fields. Mid-season spraying of herbicide-resistant crops means growers may be applying non-selective products when everything is up and growing. Greenhouse expansion in southwestern Ontario is moving outside of traditional areas. Field crops and greenhouses could be situated on adjacent farms. Strip cropping is being used by some growers and requires the utmost in spray drift prevention, as 2 different crops are grown in alternating strips.
So just how effective is this new nozzle technology in reducing drift? Research conducted by the Alberta Farm Machinery Research Centre has shown a significant reduction in spray drift.
On this graph, we will assume that the drift potential from extended range flat fan nozzles is 100. Both the extended range flat fan nozzles and the standard flat fan nozzles have been used for many years to apply herbicides. Switching to a turbo flat fan nozzle of the same size and operating at the same pressure has a drift potential of 50, or half that of an extended flat fan nozzle. A low-pressure air induction nozzle will have a drift potential of 25. And lastly, a high-pressure air induction nozzle will have a drift potential of about 13. In summary, research has shown that air induction or Venturi nozzles do reduce spray drift significantly, anywhere from a 75 to 90% reduction compared to traditional flat fan nozzles.
But do air induction nozzles produce the same pest control results in the field as conventional nozzles? Well, Tom Wolfe, a researcher with Agriculture and Agri-Food Canada, has run efficacy and coverage trials at sites in Ontario and in Saskatchewan. In over 100 trials, Wolfe says the new air induction or Venturi nozzles work just as well as conventional nozzles. But he says it's important to choose your nozzles carefully based on the type of weed that you are spraying.
With regards to efficacy and coverage, the Venturi nozzles have a range of droplet sizes that they produce, and some of those may be too coarse for adequate coverage on some weeds. What a farmer would have to assess is what weeds are present. If grassy weeds are present, you will want to have a slightly finer spray. You can still go to an air-included spray, but it ought to be on the finer side. That means choose a nozzle that initially produces a finer spray or elevate your pressure to produce that finer spray. If you have broadleaf weeds, typically you can go with as coarse a spray as you want. Broadleaf weeds typically retain big droplets relatively well, and we have not had any efficacy concerns. Difficult to wet weeds are not a very good target for a very coarse spray. When you have a difficult to wet weed like a grassy weed, you want to go to the finer side of the spectrum. You want that drop to attack the weed a little bit from an angle. And so you can angle your nozzle slightly, or you can go to a finer spray where droplets inherently go towards that kind of a target. But there are also broadleaf weeds that are difficult to wet. Take lamb's quarters. A large drop is much more likely to bounce off even a horizontal target like lamb's quarters. And so we'll want to have a slightly finer spray there. But again, you don't have to overshoot the fine spray. We don't need to go as fine as we thought we did.
One limitation of Venturi nozzles has to do with a narrower window of opportunity in the spring for pre-seed burn downs. For optimum coverage and efficacy, it may be important to delay your burn down until the small weeds are a little bigger than would be required with conventional nozzles. The coarser spray supplied by the Venturi nozzles may miss the plants altogether if they are too small. You will want to wait until the small weeds are a little bigger. This shortens your spray season, but extends the number of hours during the day you can spray because there is less drift. You can gain additional flexibility by having 4 nozzles on the sprayer in a multiple nozzle turret.
Every farmer that is either buying a new sprayer or has an opportunity to update their new sprayer should consider having about 4 nozzles on that sprayer in a multiple nozzle turret. The 4 nozzles that we recommend are a lower volume nozzle, perhaps for a glyphosate application, and then a higher volume nozzle for everything else. And then you would like to have a low drift version of each of those nozzles. That greatly extends the time of spraying. You can do a pre-seed roundup. The winds come up, you've got something sensitive downwind, you can switch to a low drift nozzle and get the job done.
So air induction nozzles do provide good pest control. Where can you buy them?
Air induction or Venturi nozzles are available from a number of companies. At present, there are some 10 manufacturers offering these tips in a variety of sizes. Not all companies offer the same range of nozzle sizes. Some nozzle designs may require special caps to accommodate the tips. Like any other piece of equipment, air induction or Venturi nozzles must be used properly to be effective. You must follow manufacturer recommendations regarding nozzle spacing. This is critical to ensure proper nozzle overlap to get uniform spray distribution across the whole boom. Operating pressures are also important because Venturi nozzles have a lower pressure output at the exit end than conventional nozzles. Operating at too low a pressure can cause your spray pattern to collapse, which causes coverage and efficacy problems, especially if you have to slow down. Keeping your operating pressure in the mid to high range is crucial because that will help maintain a good spray distribution pattern.
The first question a farmer should ask to make the right nozzle choice is, how high pressure can my sprayer produce? If your sprayer can only produce about 50 psi, the choice is pretty simple. You have to choose a nozzle that will work well at lower pressures. The Turbo T-Jet is still a good choice. The Air Bubble Jet is a good choice. Perhaps the Lurmark Ultra Low Drift is a good choice in that category. All the other nozzles become, I think, bad choices because they typically require higher pressures. Now, say you can do higher pressures, then a whole new crop of nozzles becomes available. The Greenleaf Turbo Drop or the XL, the Hardy Injet, the T-Jet Air Induction are probably the top contenders in that category. They are all very comparable. I think I would caution people to use these nozzles at low pressures. They are already very low pressure and very coarse sprays. You want to operate any Venturi nozzle in the middle of a reasonable pressure range so that if you have to slow down, that you can and you still retain a good pattern.
How well do these new nozzles wear? Helmut Spicer of the Ontario Ministry of Agriculture, Food and Rural Affairs says that although wear testing data has not yet been collected, the new nozzles should last even longer than conventional nozzles.
The cost for air induction or Venturi nozzles is about comparable to standard flat fan or extended range flat fan nozzles. There's been nobody do any significant wear testing on this nozzle technology. Although when we look at those nozzles, the metering orifice is round as opposed to a sharp edge elliptical orifice, which is used in a flat fan nozzle. And because of that round orifice, it should wear better or should wear longer than elliptical sharp edge orifice. I think we're going to get every bit the performance out of them that we've come to expect from traditional nozzles.
Whether you call them air induction or Venturi nozzles, this technology can help you reduce spray drift. But like everything else in farming, low drift nozzles require you to make informed management decisions.